Hi, I'm Jeff Ranke, Editorial Director of Manufacturing.net and Manufacturing Business Technology. Welcome to Security Breach. Those of you with a military or law enforcement connection are probably, and unfortunately, familiar with the term collateral damage. While this phrase has a legacy in those environments, it's also become an unwelcome addition to the realm of cybersecurity. And, not surprisingly, using collateral damage to describe the impacts of a hack has increased in parallel with the rise of attacks on manufacturing and critical infrastructure, and in describing the victimization scheme plaguing the industrial sector. Examples of this dynamic can be found in a number of hacktivist attacks that targeted infrastructure in a certain region, but either through unrealized connections or bad actors following the blueprint, impacted vital medical and production facilities across the globe. But perhaps the best case studies are found in the supply chain. Ransomware attackers have found that extra pressure can be applied by hitting one link in a vital supply chain. Whether that soft spot exists in the material supply, production, logistics, or retail sector. The additional pressure being exerted on these entities to get up and running by their partners or suppliers helps to internally legitimize decisions to pay the ransom and move forward. While both examples demonstrate the unintended consequences and victims of an attack, they also showcase that hackers are not concerned about this collateral damage and will use it to obtain the data, money, or disruption they crave. Here to discuss some of these and other types of exploits, along with some solutions and strategies, is Jason Oberg. He's the CTO of Cycuity, a leading provider of vulnerability mitigation solutions. Jason, thanks so much for joining us, and welcome to Security Breach. So I don't typically start these conversations out this way, but you have kind of a unique approach, Cycuity does, in terms of the way that you go to market and the way that you work with the manufacturing sector and in approaching a lot of these vulnerabilities that we're hearing so much about right now. So I thought maybe we could kick the show off by just talking to us a little bit about the company and some of the areas that you're focused on.
Yeah, no, absolutely. So, we're in a unique space in the cybersecurity market. We're specifically focused on hardware and actually specifically semiconductors. So we're really looking at identifying security vulnerabilities that are typically, hidden below the scenes of software. I think there's a lot of assumptions in the broader cybersecurity community that, the hardware is inherently secure, and I'm going to build different protections on top of that. But the problem that we're really seeing is that there's a lot of hardware feature sets that are actually being actively exploited, both from a physical access perspective, like there's actual, you get the chip and you can change the voltage and power and the temperature even and cause some behavior, but also just actually a lot of these can be done remotely because a lot of these hardware vulnerabilities are actually baked into the fundamental way that they process data. And so we've seen things like these meltdown and Spectre vulnerabilities, which hit a lot of the large processor vendors like, Intel, AMD, and ARM, and so on. And so our products and our focus is really on addressing those specific types of vulnerabilities or preventing them.
So when we look at these from when they're actually used or the applications that they're placed into, is this something where it's a compatibility? Is it an endpoint type of vulnerability? Is it a data risk? What are some of the bigger things maybe you're seeing there, the vulnerabilities that you're looking to address proactively?
Yeah, no, that's a really good question. And the fundamental, the thing about hardware is it's so foundational across everything, right? So, obviously depending on what market you're in, the actual chips can vary, right? So you're not going to have a very large scale data center processor in a smart meter or something like that, right? But the fundamental vulnerability landscape is pretty common, right? And so we've seen issues, like I mentioned these meltdown Spectre vulnerabilities, which typically have targeted data centers, laptops, these types of things, because the processors that are used in those are pretty high performance. But similarly, we've seen vulnerabilities in IoT devices from microcontrollers, because if you think about hardware, it's really responsible for bringing up the system in a secure state, right? So the whole concept of secure boot, making sure the actual software that's going to get loaded onto the processor, as it starts, is authentic, it hasn't been tampered with. All of those types of things can have issues that can break down. And if attacker can exploit that, they can put their own software on a device, which allow them to kind of root a device, or they could, potentially change the behavior, or actually find a vulnerability they could then exploit in other devices. So that's the kind of, it's not, from what we've seen, it's not really specific to I would say, a specific end application. I know that, like I said, there's areas that tend to have more focus by adversaries than others, but it tends to be pretty common across the domain because hardware is sort of a general thing across all applications.
Yeah, it's just interesting to hear vulnerabilities in hardware being such a focus. Was there some sort of event or turning point that made you look this direction as opposed to everybody else who's looking at network scanning and looking at everything from that perspective?
Yeah, that's a really good question. So, I mean, we I think when we first started the company, so I'm one of the founders and CTO, right? So when we first started the company, I think we were a little too early in the market, right? So people were like, what is this space? But we had done I did my PhD in this area, and so we had some kind of deep expertise. But I'd say really sort of right around 2018 or so when these Meltdown Spectre vulnerabilities came out, I think that was there was already, we already had a lot of customers using our products at that time, but when that came out, I think from a public view perspective, that was like a really like big eye opener for just the general public to say, wow, there's actually like you can actually exploit these hardware vulnerabilities remotely, and these are things that we really need to take seriously. And we saw companies completely reorg, form full security teams, so a lot of the semiconductor companies. So it's a pretty big event. I think that was probably a kind of a landmark event. And then following that, there's just been a lot of, variants and follow-ons to that since.
It's interesting, when you're detecting these things in such an kind of an advanced state of production or pre-advanced, what's the reaction typically like with the folks that you're working for? Are they more relieved? Are they frustrated because basically they have to start over and fix all this stuff, or how do they respond to that?
Yeah, it's a really good question. So the interesting thing about semiconductors is that it's an old market, right? So I mean, it's trying to think back when the first transistor was built. I don't have the date in front of me, but this is decades old, right? So some of these companies have been around for a long time, and they have their ways of doing things. They have their processes. They're not this new venture-backed cybersecurity company that's building this new widget that's 5 years old, right? And so the mindset is definitely an interesting one because they're so used to time to market driving. It's all about getting silicon out the door. The faster you get chips shipped, the faster you can start recognizing revenue from those chips and so on. And so this whole notion of we have to add in this layer of security review has been challenging for certain companies, right? So I think it's required a mind shift, and that's happening across the industry. I mean, it's pretty ubiquitous, but there's just like in any market, there's leaders and there's laggards, right? And so we see that transition happening pretty much across the board. It's just interesting to see how some people or some organizations are way ahead and some are pretty far behind, and sometimes that's surprising. You think a company's very far ahead because of what they market from a security perspective. They have a bunch of features and they're out there saying they can secure all your data, but their processes internally, when you look at it, are pretty limited, right? And then conversely, we have customers that are pretty far ahead, even though you think they wouldn't be. So when the response is always challenging for some of them because a lot of times they get hit by something new or something happens and they don't have the infrastructure to respond effectively to that. So it's pretty scary, honestly. So.
Well, that's really interesting. Working with a semiconductor manufacturer who we just perceive as this extremely high-tech, more advanced sort of production facility, and they're struggling with a lot of the same things that we see in a lot of manufacturers in terms of adapting that internal culture that embraces cybersecurity and what it can be to help improve their production flow and ultimately their products. How ingrained or how close are some of the partners? In other words, we know that the chips are made here and it's going to be going into this device further down the road. Are you working with any of those folks as well, or what's the dynamic there in working with the chips and then the folks that are getting supplied the chips?
Yeah, no, that's a really good question. So obviously the semiconductor ecosystem is somewhat fragmented, right? There's a lot of different stakeholders, right? So typically you have the chips being actual designed. So like, when you actually build a chip, you're actually writing code. It's in what's called like a hardware description language, but it essentially looks like code. And so most of those engineers tend to be, local to the headquarters of the company. So like if it's a US company, those engineers tend to be here. The manufacturing for most of these chips tends to be at in Taiwan, for example, TSMC, they're one of the largest fab manufacturers. Intel has a foundry services they've started. So they started to actually manufacture other non-Intel chips there. That's a new business offering that Intel has. So that's kind of another stage, right? And then you have the whole packaging aspects, you have the delivery aspects. And so where we focus is on the design side primarily, because that's kind of the entry point where if there's a design bug that can be exploited later. But there's a lot of issues to be addressed across that whole supply chain. So for example, there's a big, you know, there's a big congressional law that was passed called the Chips for America Act that has like $50 billion allocated over the next 5 years, I think. But a lot of that's been focused on on the supply chain kind of access to semiconductor standpoint. So really funding, subsidizing, building onshore manufacturing, more for supply chain stability than like vulnerability prevention. But again, it's a very much there's a lot of components of this that are challenging, at least from a vulnerability standpoint. You know, the doing something on the design side would be significantly easier than like inserting something out of fab from our perspective, right? So because it's just code, right? So if you licensed some technology that you integrated that had a bug, you wouldn't know, right? Just like you would in software, or it would be hard to figure that out in software as well. And then if you have a designer that's nefarious or whatever, it's much easier to do the attack at that domain, because if you succeed there, regardless of where it's manufactured, you have the most secure facility ever. The behavior of the chip is going to still be vulnerable. So we're primarily focused there, but you're right. There's a lot of different stages across this that require attention. So.
Well, and I asked that because we're seeing those supply chain hacks become such a bigger part of what manufacturers have to deal with, regardless of what it is. One of the bigger ones that we've talked about on the show here is one with Dole Foods, and it just had such an impact further down the line out of just that one production facility that was hit. So in working with the chips folks, are they putting more pressure on some of these other folks that are involved in their supply chain, or is there a greater awareness throughout that supply chain of, hey, it's great that the chip, we've addressed a lot of the vulnerabilities there, but there's still a lot of places that the hackers can get into if we're not careful? Is there a greater dialogue going on there?
There is. I think definitely it's interesting because there's two camps, right? If I speak of this broadly, you have the government camp, which is, the more the CHIPS Act type of activity where they're trying to just broadly protect America's access to semiconductors. And then you have more the conventional commercial market. From what we've seen, there's primarily the government wants to make sure that they can continue to get access to really latest technologies and so on, and put a lot of manufacturing onshore. The conventional commercial semiconductor market view hasn't been as concerned about vulnerability insertion at other parts of the design or the supply chain. It's been mostly on the design side. I think they've generally been concerned on the commercial side with access, right? Like, so if they have a disruption in their supply chain, then they can't sell chips. We had the big chip shortage in like right after COVID because everyone was buying all sorts of electronics and stuff, right? So, I think they obviously want to prevent that because that impacts revenue, but I think they're less concerned about vulnerabilities. Whereas the government side, they're concerned around, vulnerabilities across everything, right? So from, counterfeits, for example, are a big concern because you can just, take a chip, you can change what's on the markings of the chip, the silk screen, and say, oh, it's this other part, and someone puts it in and it does something nefarious, right? So you might remember that there was this big Supermicro Bloomberg article that kind of talked about some of this spy chip that was put onto a board, that kind of stuff, right? So there's definitely concern on the government side across all of that, but I haven't seen as much from a vulnerability standpoint on the commercial side for other parts of the supply chain. It's been very much on the design side, because that's what, if there's an issue in the design, that's what's ultimately going to get deployed in the final product, right? And if there's a vulnerability there that an adversary can attack, that's going to affect the end, their end customer and so on. So.
No, it makes sense. And I'm glad you brought up the CHIPS Act. I mean, that's something we talk about across our brands here in manufacturing quite a bit. Obviously, the big news, whether it's Intel or Samsung building these huge facilities here in the U.S., with those additional resources, and I understand, like you alluded to, a lot of that's going into the physical manufacturing or construction of these facilities. Has there been additional resources that has enabled these chip makers to also sort of strengthen or ruggedize some of the defensive or the security measures that they want to embed into the design of their products?
There is, yeah. So I think the primary purpose of the core CHIPS Act was, it seems like, obviously I'm not directly involved in the activities, like I said, directly. But what I've seen is that most of the large dollar amounts are really for, subsidizing manufacturing facilities, right? Because that costs a lot of money. But at the same time, if you start unpacking it, there's, for example, part of the CHIPS funding went to DoD. It's called, I think it was called CHIPS DoD, but there's a whole initiative that's getting funded called the Microelectronics Commons that's trying to focus on just generally building out a semiconductor ecosystem. So better design capabilities to build, 5G and 6G technology chips, AI chips, all sorts of stuff to just try to stimulate our, the country's ability to create, new stuff. And as part of that, security is really important, right? And so we see a lot of that getting filtered into there. And then there's other programs, for example, called the Trust and Assured Microelectronics Program that's also at a DoD that's focused on, making sure the chips we design are secure and these types of things. So there's, at the very top level, the big dollars you see, like I said, are going to manufacturing facilities. But underneath that, there's initiatives that really focus on the whole problem. So there's definitely activity going on in that space.
Absolutely. Is there, and again, I know you're on the hardware side of things, but is there a lot of conversations that you're having with these chip folks about the whole Secure by Design initiative and how some people, they really get in up to their elbows and others are really relying on somebody else to deal with it? What are those conversations like with the chip folks, and what's their perspective in terms of their role sort of in that whole Secure by Design dynamic?
Yeah, no, so it's sort of the who's responsible thing, right?
Yeah,
So the interesting thing, like I said, because obviously what happens on the chip side is they'll develop the chip, they send it to somebody, they might provide like a reference software design, but then it's like, okay, now it's your problem, right? And so what I found that some companies are doing effectively is sort of being very transparent about where they're responsible and where they're not, and where it's a shared responsibility. So we see that a little bit more happening a little bit more frequently where they're being a lot more open and transparent about that, where they say, I will be responsible as a chip vendor to make sure the part boots securely, that, our hardware root of trust is behaving as expected because they control all of that. So that's kind of what is going to load all the firmware and the chip up in a secure state. And then they say, okay, well, once, we'll do that. And then when it comes to the end application and how you use the features of the chip, that's on you, right? As the consumer of the silicon. And so we see that happening more and more. It's still it's not across the industry, but that's the kind of shift that we see happening. It's really important because, you're always going to have this, unless you're a completely vertically integrated company like an Apple or a Tesla that actually is, Apple builds their own chips, their own, boards, their everything, right? And so they can control that a lot more. But as soon as you get to a conventional semiconductor company that has this a little bit more of a fragmented ecosystem, you have to have that transparency. Otherwise, people are just going to make mistakes. And so conventionally, it's like, here's the chip, go build your design. And then the end user screws something up and it becomes this huge mess, right? Like, it wasn't our problem, so on and so forth. But I see that being more transparent being a trend lately. So
has that transparency been a problem? I mean, in the security community, transparency is not always the easiest thing to achieve. How has that gone?
Yeah, no, it's a good point. So when I say transparency, it's not like here's the actual issues we've identified necessarily. It's not at that level of detail, but it's more like here's the general scope of what we've actually validated. Like we'll take responsibility for this piece of it, but Gotcha. We're not going to take responsibility for that other piece. That's more of what we see the dialogue happening. So
I think
it provides clarity to the user of the chip that, I don't need to worry about that. I can trust that and then work on this. And if there's a problem, they know who to go talk to, right? Part of it, one of the, just give you an example, right? So like when Meltdown Inspector came out, it was such a new thing. It exploited a lot of the core performance features of a chip so that you could actually, like, in a simple form, if you have two different software applications running on the same chip, one, like if one is adversarial, it can actually learn information from the other chip process that's running, but at an operating system level, they're like totally isolated. So from a software perspective, they look isolated, but the hardware was leaking information. And when these came out, a lot of these companies, like it affected like, Red Hat and like, actual server infrastructure, right? And so it's like they were trying to patch stuff, but then it was unclear who needed to do what across that ecosystem, right? And so it was actually a huge mess for a long time. And so I think being transparent about here's what I'm going to be responsible for and here's what you're responsible for just helps manage issues as they come up more effectively and in a more organized way as well. So.
No, I think that's incredible momentum in the right direction in terms of defining those roles and just having that level of accountability that is it's so important on a proactive level in terms of making sure things are resolved before they become a bigger problem. So that makes a ton of sense. Mm-hmm. Looking at chips specifically here, we hear a lot of stuff going on right now around security, focused on, especially the Biden administration, focusing on China, what we're allowing them to look at, how much we can work with different suppliers. A lot of that relates back to a national defense perspective. So it's great to see a lot of movement there in terms of making sure anything we're doing from an electronic component perspective is secure. In the industrial sector, we have those same concerns, but it focuses on automation equipment and machinery and other things where we need all of that data to be processed as cleanly, as effectively, because we can't shut down. We got to keep moving. Are you seeing any disparate sort of priorities or perspective being placed on DoD that maybe hinders some of these other industries where we depend on these chips a great deal?
Yeah, so are you saying, asking about the DoD's dependence on commercial chips? Is that what you're referring to? Or
I'm saying, are we focused more on certain applications like defense and then maybe not paying as close attention to things that we would use on more the industrial level, the commercial manufacturing level?
Oh, got it. Yeah. So I think they're very kind of separate worlds. So I think just generally the actual defense market for the commercial semiconductor companies, like an Intel or a Qualcomm or what have you, is very small relative to their commercial business. And so most of what the DoD is focused on is, how do we get better access? How do we trust? Because they want to be able to consume from the commercial market because it's the best technology. The problem is it's hard to trust that. And so what happens with the DoD is they tend to build a lot of stuff custom because it's like, well, this thing was built, designed in California and then verified in India and then manufactured in Taiwan and then packaged, so like that scares them. And so there's a very key focus on how do we actually build more trust in that supply chain so we can actually consume the commercial chips. From a vulnerability standpoint, I think the commercial companies are still motivated on what their biggest market is, which is the commercial side. So they're really focused on preventing vulnerabilities that can affect a lot of their commercial business. But obviously, they will make investments in areas that the DoD is interested in or the government's interested in if they get funding to do that, right? So the government's subsidizing them to actually do activity that says, hey, add this feature set or add this capability that will help us. A lot of the commercial companies will be open to doing that, but their main driver is still a lot of the key commercial aspects. But the DoD benefits directly from that because, like I said, hardware is pretty much, regardless of what application it's in, the vulnerabilities are pretty common. And so if the commercial companies fix something for their, commercial semiconductor companies fix something for their commercial customers, that's going to benefit the DoD.
Okay, so Jason, one of the big things whenever we talk about security in the industrial realm or really across the board is artificial intelligence. Somebody's always talking about it, and some people we get an eye roll from because they're sick of talking about it. But in this sector, it would seem especially important to discuss. What are some of the bigger impacts that AI is having specific to some of these chip makers and what they're dealing with right now?
Yeah, no, so the interesting thing that I see happening, right? So obviously AI requires a lot of compute power, right? And so there's a huge focus in the semiconductor space to build chips that can help accelerate that computation in a simple, whether it's training or inference or what have you, right? And so there's tons of startups in this space building chips that can help with AI computation, both on the edge as well as in, like I said, on the training side. And obviously there's a lot of commercial focus by the commercial semiconductor market. Obviously, NVIDIA with their conventional GPU graphics applications have seen a huge, I don't know what their market cap is, but obviously it's over $1 trillion. I don't know what it is today, but right, there's a huge growth in hardware, using hardware to really accelerate AI applications, right? And I don't think that's going to go away. The thing that I see, so less about like how AI is being used to attack hardware and these types of things, but generally speaking, like I had mentioned, a lot of the core vulnerabilities in hardware tend to be pretty common. And what scares me personally is that I see a lot of focus on getting chips out to market as fast as possible, especially for some of these smaller companies. And whenever that's a driver, security is not a priority because it's like, I mean, they have investors, they have board members. They're saying get the silicon out the door, right? Which totally makes sense. They have to get stuff shipped and start generating revenue. The concern is that if security isn't taken seriously for these chipsets, then a lot of the actual models that are programmed on the chips could actually get stolen because they're not protected. They're not encrypted, they're not authenticated. You could actually load false models onto the chips that are nefarious, that mispredict and misinfer results, right? And so these are very common things that you would typically see in like a general, making sure that the your operating system that's booting on your chip is authentic, right? It's kind of the same model, but the actual models that are actually being, AI models that are actually being programmed on the chip need to be protected from both a confidentiality and an integrity standpoint. And I think that isn't a focus, and that scares me because you have chipsets going into autonomous vehicles, detecting objects and so on. If there's some sort of vulnerability that can be identified that could then be exploited across other, across the domain of, across all chips of that type, that's really scary, right? And so that's where I see some of the biggest gaps from a security perspective on the hardware side, is that isn't a priority. And I understand why it's not, because they're, like I said, they're trying to get chips out the door and get things, just hit the baseline of making stuff work. But if that isn't taken seriously, I think something's going to happen. And we saw this already with a lot of the application processor issues, where everything was all performance. And then there was this huge security issues that came up, and people are getting very smart about how to hack into these chips. So I think there's people watching it. It's not like no one's cared about it. So that's where I'm most nervous.
Well, and it's interesting because what you just described is a general attitude throughout manufacturing. You've got some folks who are just, like you said, and it's understandable, we need to get product out the door. We need to be mindful of time to market constraints and all of that. I know there's no silver bullet here, and if you knew that, you'd probably be retired on a beach someplace. But is there something that you've seen, whether it's an internal tactic or messaging, that's really helped organizations get it and sort of flip that switch over into making cybersecurity a priority when they're developing these chips and before it goes out the door and making those investments?
Yeah, I think so. I do think it's pretty. If you go to any executive across the semiconductor industry and ask them, is security top priority, they will say yes to this question. Yeah. I think the issue is where they are in that life cycle, right? So some have actually. So let me take a step back. Pretty much every one of these companies has some sort of security infrastructure. They have someone that's in charge of security at some level. It's just a matter of how sophisticated that is. So they are making investments. They are doing things. They have security features. They know that they don't want to, they could be vulnerable, right? And so I think that awareness is there. I think where things shift across the different companies is how sophisticated they are in that process. So some have really good infrastructure. They have a whole, incident response team. They have, a whole process for actually defining security requirements up front based on their threat models and kind of going through a typical security design life cycle that you would see in the software domain. And then there's other ones that are a little bit more patchy, ad hoc, that aren't quite there yet. But I do think across the board that mindset is there, and folks know they need to do something. And every year it seems the sophistication and in those processes across the industry is improving. So that is encouraging.
Well, it kind of leads into my next question, because when you talk about hacking into a semiconductor, that's, as you just mentioned, really scary potentially. I mean, they can get in there and do any number of things, from shutting down the device or equipment, extorting the company that owns it for ransom, stealing data, whatever the case may be. So confronted with all of that knowledge, Jason, what helps you sleep at night? Like, how do you not lie awake at night wondering how we're going to figure this out? And I ask that not to fearmonger, but because I think there is some movement there. I mean, what are some of the positive things we can talk about that we're doing to help prevent some of these bad things from happening?
Yeah, no, it's a really good question. I mean, and just not to reemphasize the fear mongering, but like, chips are some of the most complicated devices that humans have ever built. Like, they're really, really complicated, and the amount of things happening in, like, hardware inherently is very parallel. So like the amount of stuff that's going on at the same time within a chip is astronomical, right? So it's, when you start getting in there and looking at some of the security issues, it's pretty scary that that some of our processes aren't as good as they should be from a security perspective. So that's what keeps me up. And then I think what kind of makes me at ease a little bit is that the fact that I think there's an awareness to the problem that people are actually moving towards it. So I would be way more scared if there was complete ignorance and it was like, we don't have a problem and it was like a ticking time bomb. I think there is awareness, and there is, like I said, organizations are being more proactive. They really are focusing on addressing the problem. And so that makes me feel better, because every year we see that type of process improving. But there's still a lot, there's still a long way to go. We have a lot to do still for me to feel good that these chips are actually secure out there.
Yeah. It's a similar vibe throughout manufacturing. I think Colonial Pipeline was just like a real landmark event. It really opened everybody's eyes into how vulnerable they really are and what can happen if somebody starts coming after you. So I think we're all moving in that right direction, and I think that does offer a lot of solace when we look at what's going on right now in the marketplace. So,
Yeah,
Jason,
absolutely.
this has been great. Really appreciate a lot of the feedback and understanding some of the parallels between a highly technical product like this as well as the rest of manufacturing. So as you look forward, I don't know, next year and a half, something like that, whatever the case may be, are there some bigger trends you see out there that could really be impacting cybersecurity for chips across the board, whatever the case might be?
Yeah, I think a couple of things. So one, there's I mentioned the CHIPS Act already. I think that's something that's really important to keep an eye on, because that is having a good benefit also on the commercial side, because the government is subsidizing activity that benefits the nation as a whole. But that's going to help, it's going to actually improve the security of the chips that we consume as consumers in the commercial market, whether it's in your phone or laptop or what have you, right? And so that's one trend. The other thing I would just highlight is that there is a lot of work focused on different hardware security related standards. For example, in automotive, there's a ISO standard called 21434 that's focused on automotive cybersecurity. And that's actually flowing down all the way into the actual chip manufacturers. So the actual chips that are getting put into a car are having to be ISO 21434 certified, which is good, because that forces this process that I've been kind of talking about a secure development lifecycle, being proactive, identifying the security requirements, and so on. And so I think that is a good trend that will hopefully kind of bleed into other markets. But at least on the automotive side, that's an interesting trend to keep an eye on. So
Thanks, Jason. And for more information on the company, you can check them out at cycuity.com. That's CYCUITY.com. I'd like to thank you for joining us today, and to catch up on past episodes, you can go to manufacturing.net, IEN.com, or mbtmag.com. You can also check Security Breach out wherever you get your podcasts, including Apple, Amazon, and Overcast. And if you have a cybersecurity story or topic that you'd like to have us explore on Security Breach, you can reach me at jeff@ien.com. For Jason Oberg, I'm Jeff Ranke, and this is Security Breach.